A farmer wants to construct a rectangular corral with 400 feet of fence. One side of the corral will be formed by a barn and requires no fence. 3 exterior fences and 2 interior fences will divide the corral into 3 rectangular regions. What dimensions of the corral maximize the enclosed area? All right, let's first draw a picture. Here is our fencing. We will let this side be the barn, so it needs no fencing. And then we need to divide our corral with the 3 exterior fences and 2 interior fences. And we want to maximize the enclosed area. So let's go ahead and call this length here y, and that's going to be the same for each of these fences, and we'll call this length here x. And so our maximum area is going to be x, y, but this is what we're interested in maximizing. But let's go ahead and write an equation that adds up our fence. We have 1, 2, 3, 4 y plus an x will equal our 400 feet. So now, since we have area as a function of x and y, we could solve this for x and have 400 minus 4y, and we can put that in for our x here. So we now have our area equals 400 minus 4y multiplied by y, and if we multiply that through, we have 400y minus 4y squared. We are interested in maximizing that area, so let's take a derivative. That's going to be 400 minus 8y, and we are interested in where that derivative equals 0. So when 8y equals 400, and dividing both sides by 8, when y equals 50. Okay, let's check out the second derivative. Second derivative is just going to be negative 8. Second derivative, always negative, tells us concave down, so we have on a continuous function a maximum. So maximum when y equals 50, well, that means x equals 400 minus 200, putting the 50 in right here. So that's when x equals 200. So we've got our answer. Basically, what dimensions of the corral for closing maximum area? We need to make each of these pieces that go perpendicular to the barn need to be 50 feet, and then we need to make this length here 200 feet.